Okay, there's a couple of things I want to talk about before doing the problem. And I want to talk about the tan of a double angle, 2 theta. If I were to write this down, I'd probably write down as sine of 2 theta over the cosine of 2 theta. And do I know the sine of 2 theta? I do. It's 2 sine theta cosine theta. Do I know the cosine of 2 theta? There's a variety of expressions I could put down. I'm just going to go for the one that I can't say most people, but that I typically write down. 2 cosine squared of theta minus 1. But there's two others you could write down. You could write down cosine squared of theta minus sine squared theta, or you could write down 1 minus 2 sine squared theta. Whatever's convenient for you. And what's this going to be? The tan of 2 theta. And that's an important fact, by the way. All right? Let me go back over here. I want to show you if that's written down somewhere. No, it's really not written down. So I'm going to say this is important to me. So when it says, why is that? I'm looking at this, and it's a double angle formula. All right? So what I'm going to do over here, just, step through it. And to do it, I kind of want to look at the arc sine function now. So arc sine of x, I'm going to say is equal to y. And what does that mean? The sine of y is equal to x, with the understanding that the y has to be on the invertible region between minus pi over 2 and pi over 2. All right? And the x, what would that be? It would be between plus or minus 1. But I'll be honest with you, I have trouble here, and I'll tell you why. Double angles for one. The other problem is that even if you just simply did pi over 2 would be bad news, by the way. All right. Now, why is that? It's going to be the tangent's undefined there. So we'll have to think about that. All right. Now, that's a more difficult thinking problem. So what I want to do is just maybe start working on the problem and see if I can get there. All right. And we'll talk about the issues that are presented up here in a moment. So the first thing I would do is probably write down that this is the tan of 2y, with the understanding that y is arc sine of x. I clearly see that right as an original problem. What does that give me? 2 sine of y, cosine of y. And what do you get in bottom? You get 2 cosine squared y minus 1. All right? Then I'm going to say, that is sort of like looking, not like it's in the key, by the way. I just don't see that. So what I'd like to do is just maybe talk about right triangles again. All right? So let's talk about that. And I'll put this over here. Right triangle down. And let's talk about it. And we'll talk about the sine of y. And I'm looking at that over there. What's it going to be? X. And this would be 1. This would be 1 minus x squared. I'm going to start writing that down, by the way. And what do you get? And again, we're writing this down. You get 2. Well, what's a sine? And again, we're looking at this over here. It's x over 1, or just x, times the cosine. What's that going to be? Again, I'm looking at that picture. It's going to be the root of 1 minus x squared. And again, this is how most teachers do it. We'll talk about the key later. What do you do next? Let's take a look at that. On the bottom, it's going to be 2, and then cosine squared. Well, cosine turned out to be this over here. We'll do that momentarily. And then minus 1. Let's keep moving along. What do you get there on top? 2x, the root of 1 minus x squared. What do you get on bottom? Well, when you square that root problem, you get 1 minus x squared, so you get 2. And 2 minus 1 is 1 minus 2x squared. All right? What I would do is look at the key and look at it. And what am I looking at? I'm looking at this over here. All right? So let's see. You know what? I think I made a mistake there. It's not that one. Let me just get my eraser out. I'm sorry about that. It's not that. It's 2x. Sorry about that. Which brings me to a point. Sometimes you make a mistake and you got the right answer, but you make a mistake in picking the wrong one. That's the right answer, C. All right? Now, granted, they're not asking about restrictions on this thing over here, but I do want to discuss it. At least we landed there, all right? And what I'm going to do over here is I just want to walk through the key again. And, that's typical of me. That's typical. That's typical, right? And we're using a right triangle for that. Double angle formula, that's typical. And then basically plugging it in and simplify it and get this over here. But I do want to talk about the restrictions of it. So I want to go back over here. I'm going to start to erase this business here. And I want to talk about the restrictions. I'm going to erase this over here. And I want to be careful about it. And someone says, why is that? Well, one thing I got to be careful about, what's allowed in, all right? So what I want to talk about is the values of the what I'm saying it is, this over here. So I want to just carefully look at that. And the first thing I notice about over here is that, looking at the radicand, that's 1 minus x squared. I mean, that has to be greater than or equal to 0. I'm just looking at that. So what does that mean? Well, 1 minus x, 1 plus x, greater than or equal to 0. And kind of looking at that, I know plus or minus 1. I'm going to shade that in. And then when you get there, well, looking at it, you would get, let's see, in the middle you take 0, and that would be positive. So that looks pretty good. Now, if you took a number after 1 like 2, it would be negative, and below minus 1, like minus 2, plugging in would be negative. So I'm going to say, just looking at that, I know I'm looking at an interval between minus 1 and 1. All right, just looking at this. Now, on the bottom, I got trouble. I know that 1 minus 2x squared cannot be equal to 0. So this would mean 1 equals 2x squared. What do you get over there? X squared equals 1 over 2, and x would equal plus or minus 1 over the root of 2. All right? So if I were looking at this, I'd say over here, you know what? It looks like, it starts at minus 1. We'll talk about that in a moment. It goes up to minus 1 over root 2. It doesn't touch that because it would be division by 0. Union minus 1 over root 2. And then it goes up to 1 over root 2. Can't touch that. Then it starts up at 1 over root 2, and it goes up to 1. All right? Now, again, we have to talk about it. And so what are you talking about? I need to talk about these endpoints over here. And if you plug it in, what would you get over here? I want to see if it touches it. So, arc sine of minus 1 is pi over 2, but this says 2 times that, and 2 times minus pi over 2. Wait a second. Let me just make sure I said that. Arc sine of minus 1 is pi over 2 is going to be minus pi. All right, let me just take a look at that. And again, someone says, why are you looking at that? I'm looking at this over here. This is minus pi over 2. And what are you doing over here? You're going to take another cycle of it. And I want to point out the length of these things over here. The length of it's just pi. All right? You know what? Maybe I shouldn't do the graph. I'll tell you why. I'm going to just bypass the graph. I'm going to look at as the circle goes around, and what do you get over here? We're at minus pi, which looks like this over here. Can I take the tangent of that? Of course I can. And if you do that, what do you get? You're going to get 0. All right? So this is fine. So you can include this. Can you include this over here? What do you get over there? Well, if you plug in, you get 2 times pi over 2, which is pi. Again, where are we plugging it in? Right over here. Can I do that? Well, that's this over here. It's still going to be 0, and I can do that. All right? So I'm safe with that. All right? So I'm going to say that this is my interval. Now, someone's going to say, what about those things you're talking about? Well, they have to be restricted over here. But I want to point out why they're being restricted in the original problem. Let me erase this business over here. I'm kind of done with that. And again, we'll look at the key momentarily. They're not asking for this, but I do believe it's important information. What happens at, whoops, sorry about that. What happens, whoops, I did it again. What happens at these numbers minus 1 over root 2? And what happens at 1 over root 2? Not in this, but in this. All right? So if you looked at that, I'm going to say 2 arc sine 1 over root 2. And what would that be? That's 45 degrees. So what do you get? Pi over 4. What's pi over 4? Pi over 2. You cannot take the tangent of pi over 2. So there's good reasons for excluding this guy over here. What's the other one I excluded? Minus 1 over root 2. Let's write that down. That's going to be 2 arc sine of minus 1 over root 2, which can be 2 times, well, the arc sine of minus 1 over 2 is minus pi over 4. What do you go over there? Minus, that's 4. Minus pi over 2. Also unacceptable. You can't take the tangent of that. So I'm going to say this over here. All right? So let's take a look at the key, see if they can agree with that. And we have this over here, union, this over here, union, this over here. I'm also going to graph it for you. Why do I want to graph it for you? To show you that this here and this here are equivalent on this interval. Thank you.